Hello students, this is Sujatag coming with our channel 10th NCERT SSC Maths with Sujata ji. Welcome in our channel. Students, before half yearly exam, glance our videos. You will get 100% success in maths. Let us see the third topic, revisiting irrational number. फर्स्ट समजून घेऊया आपण इरॅशनल नंबर्स काय आहे. इरॅशनल नंबर्स as per definition, if the number cannot be written in the form p upon q where p and q are integers and q is not equal to 0, then such a number is known as the irrational number. Okay, so here the some examples of irrational numbers, that is a pi is the irrational number, minus root 2 upon root 3, root 2, root 3, root 15, 0.10, 110, 1110, 11110. So these are the example of the irrational numbers. Get this point? Any number which do not form of p upon q, where p and q are integers, q is not equal to 0, then such a number is called the irrational numbers. Now let us see the theorem 1.2. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. पहिल्यांदा हा थेरम काय आहे तो पहिल्यांदा आपण समजून घेऊया की त्यांनी असं म्हटलंय की p हा एक प्राइम नंबर आहे, p ही अ प्राइम नंबर. ओके, आणि p डिवाइड्स a स्क्वेअर. p हा काय करतो, a स्क्वेअरला डिवाइड करतो. आता तो जर डिवाइड करत असेल a स्क्वेअरला, तर p हा a ला सुद्धा डिवाइड करणार, आणि हेच आपल्याला प्रूव्ह करायचं. पण इथे व्हॉट इज द a? a means the positive integer. a means any positive integer. So let us see how we prove this. So first, let the prime factorization of a be as. सपोज आपण a हा पॉझिटिव्ह इंटीजर आहे, सो आपण त्याचं फॅक्टरायझेशन करू. सो फॅक्टरायझेशन as p1 multiplied p2 multiplied dot 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 pn. Okay, what are the p1 p2? That p1 p2 dot 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 pn are primes which cannot necessarily distinct. म्हणजे हे p1 आणि p2 जी p1 p2 p3 up to pn, that may be same primes. हे प्राइम सेम पण असू शकतात असा त्याचा अर्थ आहे. सो नाव हिअर देअरफॉर नाव मल्टिप्लाइंग squaring a on both the sides, that is a square is equal to a multiply a. So we get p1 multiply p2 multiply dot 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 pn in the first bracket, and in the second bracket substitute value of a, that is p1 p2 dot 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 pn. Okay, so now squaring this bracket or multiplying this bracket, we get p1 square p2 square dot 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 pn square. So from this equation we say that p divides a square. p divides a square. So ह्या फॉर्म्युलावरून आपल्याला काय कळतं की p हा a square ला डिवाइड होतो. So therefore from the fundamental theorem of arithmetic, p is one of the prime factors of a square. सो आपल्याला याच्यावरून ऑब्झर्व आपल्याला केलं तर आपल्याला काय मिळतं की फ्रॉम द फंडामेंटल थेरम ऑफ अरिथमेटिक, आपण जो 1.2चा जो आपण थेरम बघितला होता त्या थेरमनुसार आपण काय करणार आहोत. अकॉर्डिंग टू द थेरम ऑफ फंडामेंटल थेरम ऑफ अरिथमेटिक, वी कॅन से दॅट p is one of the prime factors of a square. So using the uniqueness of the fundamental theorem of arithmetic, only prime factors of a square are p1 p2 dot 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 p, and p is one of p1 p2 dot 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 pn. Okay, so therefore we get a is equal to p1 p2 dot 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 pn, and that means p divides a. Okay, so this way we can prove this theorem 1.2. Okay, this way as p divides a square, then we can say p divides a. क्लियर झाला हा थेरम, अतिशय सोपा थेरम आहे. देन नेक्स्ट नेक्स्ट सुद्धा एक असा थेरम आहे आणि व्हेरी इझी आहे फॉर युअर examination purpose. This theorem is very important. Okay, so carefully see theorem 120. Root 2 is an irrational. Okay, we have to prove that root 2 is an irrational. We know that root 2 is an irrational, but how can we prove it? So assume that root 2 is rational. आपण काय करूया, आपण असं कॉन्ट्ररी आपण कन्सिडर करू की रूट 2 हा इरॅशनल नंबर नाही आहे. सो ॲज इट इज नॉट अ इरॅशनल नंबर, दॅट मीन्स इट इज अ रॅशनल नंबर. सो ॲज रूट 2 इज a rational number, then we can say that there are the two integers RNS which is not equal to 0 and such that root 2 is equal to R upon S. Root 2 is equal to R upon S. So R upon S च्या फॉर्म मध्ये आपल्याला हा रूट 2 फॉर्म करता येईल. So suppose R and S have a common factor other than 1, then we divide the common factor to get root 2 is equal to A upon B, where A and B are co-prime. Yes. आता काय होते की समजा R आणि S आहे, यांचा जो कॉमन फॅक्टर आहे तो फक्त काय आहे 1 अदर दॅन 1, म्हणजे एक सोडून दुसरा आहे. ओके, सो जर तो 1 सोडून दुसरा आहे याचा अर्थ काय होतो की दॅट बाय द कॉमन फॅक्टर आपण काय करू शकतो, रूट 2 हा डिवाइड होऊ शकतो. सो दॅट मीन्स रूट 2 इज इक्वल टू A अपॉन B. सो हा A अपॉन B च्या फॉर्म मध्ये पण आपल्याला रिप्रेझेंट करता येईल. सो व्हॉट आर द A and B? A are B also the co-prime. A are B the co-prime. Okay, so here we write that the cross multiplication of that root 2 is equal to A upon B. That means B root 2 is equal to A. Okay, so squaring on both the sides. याचा जर आपण स्क्वेअर केला and rearranging we get that is square of B, that is B square, square of 2 root 2, that is the 2, and square of A, that is the A square, and call it as the second equation. So from this equation, second equation, we can say that 2 divides A square. As the 2 divides A square, so earlier theorem 1.2, from the 1.2 theorem, we can say that 2 divides A also. So that means we can write A is equal to 2C. So in the form 2C. What is the C? C is the sum integer. So now here, आता पुढे आपल्याला काय करायचं आहे, the substituting for A in equation 2 we get. Okay, we consider that A is equal to 2C. So आपल्याला काय करायचं आता, हा जो AC आहे, A ची व्हॅल्यू आहे 2C, that we have to substitute in equation 2. So what is the equation 2? That is 2B square is equal to A square. 2B square is equal to A square. Okay, 2B square is equal to A square. Okay, आता इथे 2B square. Now here A, what is the meaning of, what is the value of A? A is equal to 2C. So I substitute here 2C and square out of. So 2B square is equal to 4C square. Square of 2, that is of 4, and square of C, that is the C square. Okay, so now here that is dividing both the sides. That is B square is equal to 4 upon 2 C square, that means 2 1s are 2 and 2 2s are 4. That means B square is equal to 2 square. So from this we observe that 2 divides B square. We conclude that 2 divides B square. As the 2 divides B square, we can say that 2 divides B. 2 divides B. Okay, so therefore A and B have at least 2 as a common factor. Okay, so this way we can say that A and B have at least 2 as a common factor. So, but this is a contradiction that A and B have no common factors other than 1. A and B, A आणि B ला कोणतेही एक शिवाय कोणतेही कॉमन फॅक्टर नाही आहे इथे. सो हे कॉन्ट्राडिक्शन आलेलं आहे इथे. So this contradiction has arisen because of our incorrect assumption. So root 2 is an irrational. So आपण assumption काय केलं? Root 2 is a rational number, but this is a contradiction that from our conclusion. So that means root 2 is irrational. Get this point? So या मेथडने आपल्याला हा प्रॉब्लेम सॉल्व करायचा आहे. सो असाच एक प्रॉब्लेम आणखीनही दिलेला आहे, तो आपण बघूया. दॅट इज प्रूव्ह दॅट रूट 3 इज irrational. In the same way that we have to do. First, assume that root 3 is rational. So that is, we can find integer a and b which is not equal to 0 and such that root 3 is not equal to 80. Okay. So now here, suppose a and b have a common factor other than 1, then we can divide by common factor and assume that a and b are co-parent. So here root 3, we assume that root 3 is a rational number. So we can write in the a upon b form. So root 3 is equal to a upon b, call it as first equation. Now squaring on both the sides, we get 3b square is equal to, here 3, doing the squaring on both the sides, we get 3 which is equal to a square upon b square. So now cross multiply, that is 3b square is equal to a square, and call it as second equation. Now therefore here from this state we can say that a square divides by 3. So as a square divided by 3, we can say a is also divisible by 3 from the theorem of 1.2. Okay. So now here we can write as a is equal to 3c. We can write as a is equal to 3c. That is c means any integer. Now substituting the value of a in equation 2, that is equation 2 is 3b square is equal to a square. So 3b square is equal to 3c whole bracket square. So the square of 3c, 9c square. So now here dividing both the sides by 3, we get b square is equal to 9c square upon 3, that is the 3c square. So this means that b square is divisible by 3. So b square divisible by 3, that means b is also divisible by 3 by using the theorem 1.2. As therefore a and b have at least 3 as a common factor. फक्त a आणि b ला फक्त एकच कॉमन फॅक्टर आहे, and that is the 3. तो 3 चा. पण जर हा 3 कॉमन फॅक्टर असेल तर काय होईल? This is contradiction that a and b are co-prime. So this contradiction has arisen because of our incorrect assumption that root 3 is rational. आपण जे assumption केलेलं आहे root 3 is rational. So हे assumption आपलं कसं आहे? चुकलेलं आहे. Okay. So that means that root 3 is irrational. Okay. So this way we prove that root 2 is irrational and root 3 is irrational. So both the examples are very important. So now note here the difference of the sum or difference of a rational and irrational number is irrational number. जर समजा तुम्ही रॅशनल आणि इरॅशनल नंबरची सम कराल किंवा त्यांचा डिफरन्स कराल तर तुम्हाला आउटपुट, तुम्हाला रिझल्ट जो मिळेल तो सुद्धा इरॅशनल नंबरच मिळणार आहे. सेकंड आहे द प्रॉडक्ट अँड कोशन ऑफ अ नॉन झिरो रॅशनल अँड इरॅशनल नंबर इज इरॅशनल. जर समजा प्रॉडक्ट करायचं असेल किंवा प्रॉडक्ट करायचं असेल कोणत्या रॅशनल आणि इरॅशनल नंबरचा किंवा कोशन करायचा असेल तरी सुद्धा तुम्हाला इरॅशनल नंबरच मिळणार आहे. बघा, इफ यू हॅव टू प्रॉडक्ट ऑर कोशन ऑफ द रॅशनल अँड इरॅशनल नंबर देन अवर रिझल्ट इज ऑल्सो द इरॅशनल नंबर. हे जे 2 नोट आहेत त्या सुद्धा लक्षात ठेवायच्या आहेत. त्या तुमच्या MCQ ला तुम्हाला खूप प्रॉफिटेबल होणार आहे. ओके. सो नाउ एक्झाम्पल 6 दॅट इज शो दॅट 5 minus root 3 is irrational. आता आपण नेक्स्ट बघूया एक्झाम्पल. त्याचं सोल्युशन बघूया याचं काय आहे ते. सो हियर is irrational number. So assume that 5 minus root 3 is rational. So आपण उलटच कन्सिडर करायचं कॉन्ट्राडिक्टरी. That is 5 minus root 3 is rational. So as 5 minus root 3 is rational, that means we can find co-prime A and B where B is not equal to 0 such that 5 minus root 3 is equal to A upon B. So here 5 minus A upon B is equal to root 3. Root 3 ला आपण काय केलं राईट हँड साईडला नेलं आणि A upon B ला आपण लेफ्टला ठेवलं. So change the sign. So आता rearranging this equation we get. आता जर आपण याचं rearranging केलं तर काय होईल? Root 3 is equal to 5 minus A upon B. Okay. So now here A is root 3 is equal to root 3 is equal to 5 minus A upon B. So that means root 3 is equal to cross multiply here 5b minus A upon B. Okay. So this way, since A and B are integers, we get 5 minus A upon B. 5 minus A upon B. That means root 3 is equal to 5b upon B minus A upon B. That means here 5 minus A upon B. Okay. So here 5 minus A upon B is rational, and that means root 3 is rational. As this is rational number, then we get also this number root 3 is also rational number. Okay. So now here, as root 3 is rational number, so this is a contradiction. So here this contradiction has arisen because of our incorrect assumption that 5 minus 3 is rational. आपण कन्सिडर केलं 5 minus 3 is rational आहे. सो हे आपलं कॉन्ट्राडिक्शन इफेक्ट बरोबर. आणि सो कॉन्ट्राडिक्शन येतं याचा अर्थ काय केलाय आपण जे अझम्पशन केलेलं आहे ते चुकीचं आहे. सो वी कन्क्लूड दॅट 5 minus 3 is irrational number. Okay. Now this way there is also the other example. Same way we can carry out it. That will show that 3 root 2 is irrational. So assume that 3 root 2 is rational. So we can find co-prime A and B where B is not equal to 0 such that 3 root 2 is equal to A upon B form. It is rational. So A upon B which is equal to A upon B. Now rearranging the terms we get root 2 is equal to A upon 3. Okay. इथे आपल्याला काय मिळतं क्रॉस मल्टिप्लाय करून टाका सरळ. सो क्रॉस मल्टिप्लाय केल्यावर काय येईल 3 root 2 here. 3 root 2 which is equal to A upon B. Okay. So 3 equal. Change the position of 3. So root 2 is equal to A upon 3. Okay. So now here A upon 3B. A upon 3B is rational. Okay. So now here root 2 is rational. As A upon 3B is rational, root 2 is rational. But this is a contradiction. We know that root 2 is not rational number. It is an irrational number. And that way we conclude that 3 root 2 is irrational number. Okay. We conclude that 3 root 2 is irrational number. So this way we complete this chapter. Okay. So students, keep watching our videos. If you like these videos, then subscribe our videos, our channel, and I'm sure that if you keep watching our videos, then you will get 100% success in maths.